Okay, what are we starting with on this problem?
86 grams of potassium fluoride.
What's the formula for potassium fluoride?
KF.
Kf. And what are we trying to find?
Ions.
We're trying to find ions. So when we look at our strategy, since we start off with mass, we convert mass to moles, and then we convert moles to, we can't convert it to ions because potassium fluoride is not an ion.
Convert it to molecules and then to ions.
We convert it to molecules, but potassium fluoride is not really a molecule. If you want to be technical, it's actually a formula unit because it's an ionic compound.
So does it matter which one?
So if it'll make y'all feel better, can we call it a molecule?
Yeah.
It'll make you feel better if we just call it a molecule? I think we can do that. So we'll call it a molecule. So let's just get to that point and then we'll go to the next step. So since we're converting from mass to moles, we want to go with this conversion factor, and y'all did that, right? Okay. So 1 mole of potassium fluoride is equal to, what's the molar mass of potassium fluoride?
58.0967.
Perfect. So now we need to cancel out grams of potassium fluoride. When you do that, you have converted from grams to moles. That's how you convert, by eliminating those units. Now the only unit left is moles of potassium fluoride. So now we can convert from moles to molecules, because that'll make us feel better to call it a molecule. And that's this conversion factor. 6.02 times 10 to the 23rd. Molecules, even though that's not accurate, we'll still call it that. And that's equal to 1 mole of potassium fluoride. Moles cancels, so now we have converted from moles to molecules. Now, potassium fluoride is not an ion. Potassium fluoride is an ionic compound. How do we know it's an ionic compound?
Wow.
Metal
Metal, non-metal.
and nonmetal. So that's how we know this is an ionic compound. Metal bonded to nonmetal. What happens to an ionic compound when you add water?
Oh,
It dissolves, but not only does it dissolve, like the particles break up, the ions within the particle break up, so you end up with potassium ions and fluorine ions. So you've added water in this one ionic compound that we're going to refer to as a molecule because it makes us feel better. How many ions do you see in this ionic compound? There's 2 ions.
so how do you tell that? Times 2
How do you-
ions how do you tell that there's 2? Because there's only 2 letters?
Because there's 2 letters. Yeah, because there's 2 letters.
Okay, so like if it said KF2,
Yeah,
is that 3 or only?
that would be 3. And if the problem was, if the formula was K, let's say K2O, you have 3 ions, right? But I could ask you how many potassium ions are there, how many oxygen ions, or how many ions. You have to look specifically at the question, and sure, you can use this and it'll help you for the most part, but at a certain point you have to do the thinking on your own and really analyze the question carefully. So your conversion factor, since we have molecules, which is inaccurate, but it makes us feel better, if you have a 1 molecule of KF, how many ions do you have in 1 molecule of KF? 2. So we just created a conversion factor. And that's what you have to do a lot of times, is use relationships to create your own conversion factors. Molecules cancels. Yeah.
Exactly.
Yep. And somebody's doing their using their sig figs correctly. 1.8 times 10 to the 22nd, and it's just ions because we're not talking about a specific ion, just ions. So you could get this question where it asks about ions. You might get something like carbon dioxide, and it says how many atoms do you have, or how many oxygen atoms do you have. So it just depends. You just have to look at the question carefully.
So do I do the same thing for atoms?
Yeah, you do the same thing for atoms. So in this case, CO2, how many atoms do you have?
3.
3. How many oxygen atoms do you have?
2.
How many carbon atoms?
1.
So don't you hope you get the one that asks for carbon atoms? Yeah.
What? Okay, so if you're going to, like, there was a question on the sapling that it was like,